Hi, welcome to the Calculus 3 lecture series. We are in this unit, we call it the vector calculus. And this is our video number 2, lecture number 2. And we're going to talk about the derivatives and the integrals of vector functions. Our first video, we talk about the definition of the vector functions. So basically, it's kind of like the parametric function we defined in the calculus 1 for the 2-dimension. And so if in the 3-dimension, basically the vector functions is, we defined like a space curves here, right? Okay, so in this video, we're going to talk about how do we take the derivative and the integrals of the vector functions here. Okay, so let's go to our worksheets here. Okay, so this is our lecture notes here, right? So, for the vector functions, if you kind of refresh your memories here, right? So we did it in our previous video. We say the vector function is, we call this RT, and we have like some of the real value functions. We call this a component functions, right? So we have f of t, then we have I, we have g, t, we have j, and we have ht, and to the k's, right? So for each components, for each like the I, j, and the k, we have real function values. So like now, when we talk about the derivative of like the vector function. So like in here, so if I wanted to find the r prime t, so basically what is the r prime t? You just take the derivative of each component function. So it will just be f of t to the I components plus g prime t to the j components plus h prime t to the k components here, all right? And then now, if you want to find the integration, so for example, if you want to integrate r, t, dt's here, so it will be the same thing. So basically, you just integrate the ab, f of the t, dt, then this will be your I components plus ab, gt, dt, this is your j components, and then plus AB, HT, DT. So this is your K components. So it's very, very similar like what we did in the real functions, right? So right now you just have a vector functions. So you do each components. So like you take the derivative of each components and you integrate each components functions here. So now let's take a look. There are a few very good characteristics about this function. We need to be careful. So the first ones here, that is pretty straightforward. If you have two vector functions, you add them together, you take the derivative, it will just be, you take the derivative and add them together. Okay, so this one we need to be careful here, right? So this is the one. So if you have here, be careful here, this is ATs, right? That means this is a real function, real value function, AT, times RTs here. Then you take a derivative. So that means if you have AT times RT, so basically, so each vector components you times this ATs, right? So it's ATI plus AT, GT, this is J components, and then plus AT, this HT, K components, right? So when you take the derivative of these ones here, so basically it's telling you for each components vector, you have the multiplications of what? Of the two real value function. So what type of the rule we need to use here? If we want to take the derivative, how? We need to use the product rules, right? So that's why they have the product rule tell you. So you seem like you do product rule for the, so you hold the RT first, you take the product rule for the A prime T, and then you hold the AT first, then you take derivative of the R prime T. So it's just like in here. Okay, so the next ones here is also, it's very, very important. And so if this is the R prime dot S prime, see here, right? So because the R is a vector and the S is a vector when they dot product. So you remember if you dot product, you just the I components times I components, right? Then add what? G components, the J components times J components here. So you can prove here, we're not going to prove here, but you can easily prove if you do the dot product and then you take the derivative, it will be the same kind of similar like the product rules here, right? So here, same like the product rules, so it will be R prime. So here I should say it's dot product ST, and the RT is here is a dot product. Okay, so the S prime T is here. Okay, so I better rewrite this. This one is here is not typed right. Okay, so this will be, this is R prime T. So you dot product ST, similar like the product rule. So then this is RT dot product S prime T. See here. Okay. Then the next one here is also very, very important is how about if you have a two vector function, you do the cross product. So the same rule applies here. If you do the cross product, you kind of use the product rule. So you take the derivative of R prime T, then cross product ST, and then you hold the RT, take the derivative of S prime T, then you cross product here. Okay, so for the chain rules here is the same. The chain rules here is just like the similars here. So you have R prime AT, so you just apply the R prime AT, then you take the chain rule for the R prime T here. Okay, so that's why we said for the, for the vector functions, it follow the same methodology as the real value function. So it's pretty, so this video is also a pretty simple and straightforward video. It's pretty easy videos here. Okay, so now let's take a look. Okay, so now let's take a look at our first example. So if RT is here, and I want to find the R prime T. So what is R prime T here? Okay, so let's take a look at the R prime T. R prime T, remember, when you take the derivative, you just do what? You just take the derivative for each component. So E to T will be E to T. So E, the derivative is 2T. And what is the chain rule? So it's 2. Now, what is the tangent T here? The tangent T is the secant square T. And the T cubed here is what? You take a derivative is 3T squares, right? So it's pretty straightforward, just like what we did before here. Okay, so the number 2 is here. I want to find the unit tangent vector. So we want to find a tangent vector. So what is tangent vector in the real number? In the real values calculus, we say tangent line is the derivatives, right? The slope of the tangent line is the derivatives here. Okay, so the first things here, so we want to find the slope at a specific point, right? Okay, so let's do it. So you said, okay, so the R prime T is just like you take the derivative of RT. So this is what? 2Ti minus 3T squared J and plus 4T cubed, what? Case, right? You just take the derivative of the R prime, then you substitute the value, just like we said, the slopes here, the R1 is equal to what? So this will be 2I minus 3J plus 4K here. Okay, now because they want to find the unit, right? So that means you need to find what here? You need to find the length of the R prime 1s here. What is the R prime 1s here? Is the square roots of the 2 square plus the negative 3 square plus what? Plus 4 squares, right? And this is my tangent line, it's a direction vector. So this will be the 2I minus what? 3J and plus 4K here. So the bottom is 29. So this is 2 over square root of 29I minus 3 over 29J plus 4 over square root of 29K, right? So this will be our tangent vectors here. Okay, so now the next example is here. Wow, I want to find out R double prime. So like I said, for this type of problem, just like we did in the calculus 1, so it's pretty straightforward. So you say R prime t is what? It's a negative sine t, right? Because cosine, the derivative is sine t. Okay, t cubed is here. This is 3t squared. Okay, now I do a R double prime t, so this will just be the negative cosine t, and this is 6t's, right? Okay, so this will be the 6t's here. That's it. Okay, so number 4 is here. They said the letter f of t is equal to t squared I t cubed j. gt is 7ti 3t squared j. I want to find ft dot gt. Okay, let's do 2 ways. The way method number 1, let's do the direct. Okay, so let's do the dot product first. Then the method number 2, let's go back to take a look at our equations here. Okay, so ft dot gt, right? So this is ft dot gt. So it will just be t squared t cubed dot 7t 3t squares, right? So dot here will be what? 7t cubed plus 3t fifths, correct? Okay, so if we just directly take the derivative of this one, we said ft/gt. Now take the derivative. So it will just be what? It will just be 21t squared plus 15t fourths. Okay? Okay, now let's use our method number 2. See here, the one, our formula. The formula say we use the product rule and then cross product. Okay, so it will be the f prime t dot product gt plus f of t dot product g prime t here. Okay, so let's take a look. F prime t is 2t, and what is here? 3t squared dot gt. gt is 7t, 3t squared plus, right, ft. Okay, so ft, so what is ft here is t squared and t cubed dot g prime t. G prime t is what? Is 7 and 6t, correct? Okay, so now let's do the dot product. So 7, so 2 times this is 14t what? Square. Okay, 14t squared plus 3 times 3 is 9, 9t fourths. Then plus t times this is 7t what? Square. T times 6. So what is here? So this is a 6t to the what? Fourth, right? Now you combined the similar term. So this one will give you 21t squared plus 15t fourths. As you can see, they equal. So you can use either way. You can dot the product out and then take the derivative, or you can use our own formulas, right? So the dot product derivative, this one will be equal to the f prime t dot product gt, then plus f of the t dot product g prime t. So it's a kind of different versions of the product rules, right? Okay, so this is the pretty simple and the pretty straight problems here. Let's take a look at the next problems here. Okay, so the next problem is here, okay? So this is interesting problem. They say I have a two space curve. I have R1 and R2, okay? They defined separately. And then they intersect at 0, 1, 0. I want to find the angles of their intersections here, okay? So the angle of their intersection. So the first, in order to find the angle of the intersections, here's first, I said, okay, I'm going to, okay, so I'm going to take the derivative of the what? R prime. Okay, so it's R prime T. So this will give me what? So this will give me 3t squared plus 1. This is the I components plus 2 to the e to tj and the plus cosine t, the k. Right? So now, okay, so we said when the, when the t is equal to 0, so let's see the R prime 1, the zeros here. So what do we have here? So I have I plus 2j, 0 cosine is a case, right? So it's a plus case here. So this is my first, the direction of my what? My tangent lines here, the vectors, right? Okay, so now the same things here. So my R2s here, my second group, my second function here, right? So I can have here the first derivative. This is a 2i, okay? Then my plus 2sj, right? So this is s minus 2 squared, so plus 2s minus 2k. All right, okay, so now I substitute R2 prime because s equal to 2, right? So I substitute 2. So this is, I have a 2i, okay, plus 4j plus 0k, right? So this will be 2i plus 4j. Okay, so remember, right? So I have two vectors, right? So the, what is their tangent? What is the angles, right? So I find the tangent line of the curve. So the angle of intersection curves will be the tangent line, will be the angle between the tangent lines here. That's why I find it in here, I find it in here. So remember in the R3, how do we find the curve? How do we find the angles of two? How do I find the angle of the two vectors here? So we said so if you refresh your memory, we said u dot v is equal to what? So the u dot v is equal to the u, v, and what? Cosine theta, right? So the same way is here, we can say here is a cosine theta. That's the angle between these two. So the length of the first one is 1 square plus 2 square plus 1 square times the length of the, here is 2 square plus 4 square plus 0 square. Okay, then I am dot product 1, 2, 1, and dot product here is 2, 4, 0, right? Okay, so now let's take a look at what is this one here. 1, 5, 6. Okay, so this is a 6, 4, 16, 20, and so this is a 20. So the dot product here is 2 plus 8, so it's 10. Okay, so if you simplify this is a little bit, this will be the 6, the square root of 30. So the angle theta is what? Cosine 30 over 6. So what is the angles here? It's about 24 degrees here. All right, so this is a pretty good problem here, right? So they tell you the two curves in the spaces here, right? So here's the key points here. So you want to find the angle of intersection. So you want to find their tangent lines here, right? So then the angle between this tangent line at this point, right? Between this tangent line at the point, and then you'll be able to find the, the angles here. So it's about 24 degrees. Okay, so now let's take a look. The next problem is here. Okay, so the next problem, let's say, find the parametric equation for the tangent line to the curve here. Okay, we already did this several times, so we know how to do that, right? So in here, they said, okay, so the graph the curve and find the unit tangent line to the same screens, like we're using the Prog 3D plot here. Okay, so the main purpose for this ones here is just want to show you what it looks like, from the calculator, from the calcplot 3D. So you can take a look at what we mean, the space curve and the tangent line. So the same things here, right? So if I want to find the tangent, so we want to find the unit tangent vectors here. So the first thing is what I do, I find the derivatives, right? So the derivative here will be 4 and the 4t and the 3t squares, right? Correct? Okay, so then at t equal to 1.5, so what is my r 1.5 going to be? My r 1.5 going to be, you plug in the, so it's 4 times 1.5, so it's 6 and 4.5 and 3.375. Okay, so that's how do you, that's what you did for the, for the r's here. Now let's also do what is r prime t here. So r prime t, we already did, I said r prime 1.5, right? So r prime 1.5, it will be 4. And then what is here? 6, right? And then what is here? 6.75 here. Okay, so look here. This is, you go to the, so here, that's why I want to show you the graph of the calcplot 3D. So basically, you go to the calcplot 3D, find the space curve, right? So you input here, right? So this is what? So this is your RPs, right? Then the same way you input another ones here. What is this ones here? Okay, so this one, okay, so I have not, okay, so I'm not finished yet. So here, this is the slope, right? Okay, so now the tangent lines here, we have the directional vector and we have the point, right? So this is my what? This is my point, right? So this is the point. And what is this? This is the what? This is the directional vectors here, right? This is the directional vectors here. So I can find my line, my parametric line. So x is equal to, you use the point, so 6 plus 4t, and y is equal to the 4.5 plus 6t, and z is equal to what? Z is equal to 3.375 plus what? 6.75 t here, right? So this is the parametric equations. Okay, so this is a parametric equation for the tangent line. Okay, so this is a parametric equation. Okay, so now when you input here, right? So the first one's here, this is the RT. That's what is this blue curve you generate, all right? And then this one's here, this is your tangent lines here. Okay, so this is your tangent line. That is the red line you generate. So as you can see, that's how is we talk about the tangent lines here, right? So that's what they touch. If you change the axis around, so you can visualize how that tangent line touch the curves here. But in here is the same way, in order to find the tangent lines, right? You find the point, you find the directional vector, and then, you put this parametric vector, you put the line to a parametric form, and then you plug in there, and you'll be able to, you'll be able to kind of draw the graphs here. Okay, so now let's take a look at our last problems here. Okay, so last problem is just say, okay, how about if I want to take the integration? Remember, so because for the vector functions, so each one is just what? Each function is just like a layer. What functions here is a components functions, right? So we can just take the integration for each components functions, all right? Okay, so now we can just do the integration by each ones here. So for the first ones here, so you really can just break this ones. Here is 1, 3. So what is here? So it's the dt. Then your components is what is I. Then plus, this is 1, 3, 2t dt. And what is that? So it's components j. Then plus, this is the 1, 3, 1 over t dt. Then what is the components? Is the case, right? So just like we did do like in the beginning, we say, hey, when you try to take the integration, it will just be you take the integration for each one. So this will be t from the 3 to 1. So this is your I components. And this is the t square from the 3 to 1. This is your j components. And what is this ones here? This is the natural log t. You integrate from 1 to 3. This is your k component. So your final answers here, this will be the 2i, all right, plus aj, and plus natural log 3. Okay, right? So that will be my integrations here. Right, so it will be a vector value is 2a and the natural log 3. Okay, so now the next ones here, I want to find the RT. So if R prime t and equal to the E2t, I minus j plus T2 plus k. Well, so this is just like we do the indefinite integration for the NT derivative. So in order to find the RT, what I need to do here, I need to integrate what? I need to integrate the R prime t's, right? dt's here. So now let's just like is here, just like we did in the, the calculus 2. So the first one's here, you integrate the E2t. So what is the E2t's here? We will have E2t over what? 2 minus 1j. So this is i's, right? Minus 1j. So it's a minus t, right? And minus tj. So this is a j component. Then t square, it will be t cubed over 3 for the k. Okay, so if you remember in the calculus 2, we said if you do f prime t dt's, right? So if this is indefinite integration, so this will be the f of t plus a constant c's, right? Okay, so now that means I also need to go to plus a constant c. Okay, remember this c is also is a vectors, right? So because my result is a vector. So when you plus c is a vector. So also, okay, so now it should tell you, so now at the what? R0, okay, so I plug the R0. That's the exactly like what we did in the calculus 2. You plug the initial values to see. So R0, this will be 2, this is 0, so 1, the I. Then these terms will be 0. Okay, and then this term will be 0. So it will be 1/2 I plus C, right? Then we say 1/2 I plus C is equal to the I minus J. So what is the C going to be? The C going to be 1/2 I, so become I. So I have what? I have And then in here doesn't have a j. I have a j, negative j, so it's a negative what? It's a negative 1, right? Okay, and then it's zeros here. Okay, so that's it. So I said my RT is here, just like we solve in the real number, it will be 2 to e the 2t plus what? Plus 1, right? Because this is 1/2. Okay, then minus, so this is I, right? Then minus the minus 1 is here. This is a t plus 1 j, correct? Then plus last 3, the c doesn't have the k components, so this will be the t3 over 3, the case here. So this is will be my RT here. All right. So like we said, this is the integration and the derivative will match exactly like what we did in our real number function. And right now for the vector function is just we have the components function. So we deal with each component's functions, right? They follow the same rules. Okay, that's it. Okay, so like I said, this is a pretty simple video as also it's a simple topic. So how do I take the derivatives and the integrations of the vector functions? Remember, you do this, you take the derivative and you take the integration for each component's function because each component's function is a real number functions here. All right, that's it. And we finished this lectures and then looking forward to talk to you. And for our next video, we're going to talk about a vector field. What is vector field about, right? So, all right, you have a good day and nice to talk to you and looking forward to, to go over the next topic with you guys. Okay, bye.